Welcome to this tutorial where I'm going to teach you how to read RFID tags. For this tutorial you'll need an Arduino, a breadboard, an RFID reader, and I'm using the RC522 reader, some RFID tags, and I bought a package where there was a blank card and a keychain tag. I'm also using some public transport card from the Netherlands and 7 jumper wires male to male. The first step is to push the RFID reader onto your breadboard. I start by powering the RFID reader, so the red wire goes from the 3.3 volt on the Arduino to the 3.3 pin on the RFID reader. I did the same for the ground, which is here the black wire. The next wire is the reset wire, which we connect to pin number 9 on the Arduino. The reset pin is marked with RST on your RFID reader and sits between the ground and the 3.3 volt. Next we're going to connect the 4 data wires. If you're getting a little bit confused which wire goes where, don't worry. In the description of this video there's a link to the course material. The course material contains a schematic showing you exactly which wire to connect where. So first we start with the green wire, which is connected from SDA on the RFID reader to pin number 10 on the Arduino. This is the serial data. Second, we have the serial clock, which is connected to pin number 13, which is this orange wire. Then we have MOSI, which is connected to pin number 11, which is the yellow wire over here. Last, we have MISO, which is connected to pin number 12, which is this blue wire. We're now all set up and we can now have a look at the code for this tutorial. So let's have a look at the code. Well, we start off by a warning on line number 17. The security of these RFID cards we're using is very weak, so do not use them for serious security purposes. And also the cards don't have a unique number, at least they don't have to be unique, so you cannot really trust that 2 cards do not have the same ID. Some Chinese cards allow the number to be changed and then you have a bunch of cards which all have the same number. From line 21 there is a pin layout table because we are using the Arduino Uno, but maybe you're using a Mega or Leonardo and then you have different pins to use for the SPI protocol. In this table you can exactly see which pin to use for what board. On line 34 we're including the SPI library, and on line 35 we're using the MFRC-522 library, which is the library for our RFID reader. So I'm now going to include this library like we do with all the others, and I'm searching for the MFRC-522, and as you can see there is a GitHub community version and you can install that and then you're good to go. 1, 2, 3. On line 37 and 38 we define 2 pin constants for pin 9, which is the reset pin, and pin 10, which is the serial data pin. On line 40 we initialize our library with these 2 pin numbers. Of course you can also skip these 2 and just enter them over here, but I find it convenient to have the pins configurable in a constant. On line 43 there's a function called dump card data, and this function dumps all the data present on the RFID tag. So if we look a little bit further here to this if, you see that if there's a new card found and if the card data is read, then it continues. So first it checks if there's a new card present and then it starts reading, and as long as there is data it starts dumping it with this function. So what we're doing here is basically we send the UID, so the unique ID of this MFRC55 to the PICC dump to serial function, and here you see PICC means proximity integrated circuit card. Well, if we continue to the setup, you'll see we start the serial monitor, nothing special. And here we say that the SPI bus needs to be initialized. Then we initialize the RFID reader. And then we dump the version of the reader software to the serial monitor, followed by a line that we say, present your card to the RFID scanner. The loop continuously calls the dump card data, and if we go back up here, as we told you before, it checks if a card is present and then it reads its data. So I'm now ready to upload the code to my Arduino, and then we're going to see what happens if we show some text to the reader. So I press upload, and I already grabbed some of my tags. I have the keychain tag over here. And then I'm opening the serial monitor. You see the firmware version is 2.0 and it says present your card to the RFID scanner. So if I take my RFID tag and hold it to the scanner, you'll see it's reading all its data and it's counting down from I don't know which number to 0. So this is all the data stored on the RFID tag. If I grab another tag, then there will be other data. And if this last one is my public transport card, so we cannot authenticate because that part is encrypted, but we can see here some kind of ID. So you can still use that card for its ID, but not for its content because it's an encrypted card. In the previous example, we dumped all the data from our card, but now we're only interested in the card ID. So let's have a look at the code. The beginning is pretty similar, but instead of dump data, we have the get card ID function over here. So it's basically the same if it checks if there's new card present, and then we read the card. But here we have defined a string, which is the card ID we read. Well, there are two cards with 4 or 7 bytes, but this library doesn't support 7-bit addresses. So therefore we only need to iterate over 4 bytes, which is actually the MFRC-522.uid.size. So what we're going to do is read the card ID and concatenate, so combine it with a string of the UID byte on position I, and we check if it's smaller than 0x10. So that this is a hexadecimal value. So if the value is smaller than 0x10, so 10 in hexadecimal, then we add a leading 0. And this is because we want the ID to have 8 positions. So if the number is smaller than 10, for example 9, then it only will take 1 position. It's a little bit confusing to know which ID we're working with. So if it's smaller than 10, then we add a 0, otherwise we just say empty string. If we read the value, then we read the hex value, which we also concatenate. So first we have the 0, if applicable, and then we add the hex value of our ID, the part of the byte of the ID we're iterating of. Remember, we're iterating over 4 bytes. So on the first position, when it's 0, it checks if the ID is smaller than 10, then it will add a leading 0 if needed, and then we take our hex value from the ID on that position, and then we basically, after 4 iterations, the card ID read contains our full ID. So then we convert all letters to uppercase and print the ID to the serial monitor. With MFRC-522 PICC halt A, we stop reading the card and then we wait again if a new card is present. So I've uploaded the code to my Arduino and I'm now going to present the various cards. So this is the keychain card, which has a card ID and it's printed in the serial monitor. But now when I grab my public transport card, if you remember, the part was encrypted with the data, but its ID is still visible. I also have some blank plastic cards which I bought together with a reader, and it has a different ID. So now you know how you can read different IDs from the RFID reader. I have a challenge for you. Make a program where I can write a certain card ID, and if this card is scanned, print access granted to the serial monitor, and if I use other cards, show access denied. You can even extend this exercise by having multiple cards ID for access granted and deny all other cards. If you have any questions, post them in the comments below this video. And if you're really stuck, download the course material which contains a solution for this challenge. I see you in the next episode.